All right, so continuing with the Algebra 2 review, we have number 4 here, and this is a simplification of an exponential expression. And yes, this -3 is attached to the parentheses, the AB squared C. I just had a hard time formatting it. So here we go. We're going to, always start with, PEMDAS, I guess. PEMDAS still rules here, where P is parentheses, E is exponents, and then of course we have multiplication, division, and then add, subtract. That's our PEMDAS, right? PEMDAS rules always. So, we're dealing with P and E here, and I'm talking about this little section right there. All right, right there. So the first thing I do, I'm just going to erase that to not distract, but the first thing I do when I tackle these types of problems is look to see if I have some groups that have, parentheses and exponents. So I'll go ahead and tackle that first and then clean things up. And I like to keep the coefficients. Yes, eventually we'll reduce the 2 and the 8, but I'd like to tackle that all at once. So we have ABC on top, ABC on the bottom. I'll go ahead and apply that -3 exponent on the top. And again, it only applies to the ABC on top, of course. And remember, when we have an exponent to the exponent, an exponent to an exponent, we're simply multiplying those exponents together to get a resulting, a new exponent. So we can actually say here, A has 1 and C has 1. They're pretty simple, thank goodness. So we can apply that -3 to all exponents or all terms here. We'll end up with this 3, or -3 times 1 is -3 on the A. B has 2 times -3 to get -6, and then C has, again, a -3 like A. Now on the bottom, we don't really have much going on here, right? We just have A, B, and C. And I try to line them up so we can do our math accordingly. Now, at this point, because we have A, B, and C both have a counterpart on top and bottom, right? They have something we can reduce there. I'm going to go ahead and take it a step further. We have some more cleanup to do. We'll probably have negative exponents here as well. All right, so I'll go ahead and reduce that 2 and that 8. So we'll have a 1 and a 4. We'll have negative out front, 4 on the bottom. And I'll just put the 1 there for clarity, but eventually I will drop it. So when we address, and then at this point, I just address each exponent individually. So I have A to the -3 and then divided out by A. So we have A to the -3 divided out by A. So we're going to go ahead and, using our rules, we're going to subtract A to the -3 minus 1 equals A to the -4. And we know a negative exponent is going to flip it and put it on, eventually, yes, we will put it on the bottom. I like to do the cleanup at the end. I've seen students go right to putting it down on the bottom, totally fine. I like to do cleanup on the end. That's just my preference. I'm going to clean this up just a bit. And then we'll have B. I'll just treat that separately here. You don't have to actually write these separately. I'm just doing it for clarity. So we have B to the -6 minus 1 equals B to the -7. And then we'll have that one, B to the -7. And then C to the -3 over C equals C to the -3 minus, or sorry, minus 1. So ultimately we have C to the -4. Okay, 4 is looking pretty lonely down there in the bottom, but we'll fix that here in a moment. So, what we're doing here, the main rules we applied are, as far as exponential rules go, are we applied that -3 exponent to that group in the top, and we multiplied those respective exponents by the -3. to get our a to the -3, b to the -6, c to the -3. And then we use our exponent rules where we have division. So that means we take our top exponent and subtract the bottom. Watch your positives and negatives. -3, -3 minus 1 is ultimately -4. -6 minus 1, ultimately -7. And for the c term, we have -3 minus -1. Of course, again, we get -4 here. So just be careful of that. But ultimately, we end up with negative. Don't forget your negative out there. 1 will have to remain because we can't just leave nothing. So the 1 will stay. We'll have 4 on the bottom, and then we just simply flip our exponents. So that's our third rule, right? We're going to flip and negate our powers. So if we have, for instance, a to the -1, I know that's 1 over a to the first power, or simply 1 over a. Same with a to the -2. I know that's 1 over a squared, and so on, okay? So if we have those on the numerator, we just need to flip them onto the denominator, and of course, make that exponent positive. So that's the third rule we used here. Again, this is very, very typical exponential problem where they'll just give you it looks like kind of a mess, but if you work through it methodically and systematically and keep track of your exponents, you can't go wrong. See you in the next video.